Good afternoon, everybody. Welcome back. We are in another scenario of none other than a free support Friday. As you guys know out there, we are here at jitcadcam. I am none other than Fusion Phil himself, here to help you guys in any way possible, as well host amazing things like this, where you guys have the freedom at any time to jump in here, ask questions, get those answers. Maybe you've been bashing your head against the wall, or what's kind of been a theme a little bit is roast my setups, right? So as anytime, if you guys have any questions whatsoever throughout today's session, feel free to throw a comment in chat. We have the live chat going as well. Or if you're watching this at a later date, there's a support email down below allowing you to go ahead and send in a support ticket directly to us, and we will get back to you at a later date and time. Now, I want to make sure you guys can hear me all right. I'm getting my stats are starting to come through. Looks like quite a few of you are already out there. Let me know in chat. Can you guys hear me? Can you guys see me? Is everything working all right? In the meantime, while I wait for those to come through, we obviously have to kick this off with the ceremonial drink for this week. So awesome. Faruka's great to see you loud and clear. Travis, always great to have you out there in chat. But we are going to start things off by cracking open the energy drink. Now, the ceremonial energy drink is brought to you by the fact that each and every one of you, if you guys come here, get some new knowledge, find something that you like, and want to give a little bit more than just a like or subscribe, go ahead, buy us a beer as well. You could buy us steaks and lobsters as well. Faruka, thank you very much. Love the beard. It's coming back. It's a neck beard. I need to trim her up and get all pretty, but let me get a sip in. Steven Casper's in the chat, which just so happens, we're going to go ahead and start sharing our screen, and we're going to kick this off in honor of him. So, of course, in typical fashion, I went ahead and made a Facebook post, and all of a sudden, we got like 8 or 9 different problems sent to us today. So, right off the bat, we have a lovely mill turn part. Now, the concentrated area that we have on this part in particular are going to be these 3 slots on the part. So the first thing I'm going to do is I'm going to go ahead and inspect that very first one. And as you guys can see, that's a diameter of 0.75. Now, presumably, I would need an end mill that exact size to cut that slot perfectly. However, we're going to be able to get away with using a smaller end mill. So from the start, the old school way to do something like this would be along the lines of doing a 2D contour. And with that 2D contour, we're going to go ahead and do a wrapped toolpath. And what we want to wrap around, again, this is anywhere that's round on your part. Moving a little bit further on, we now need to define our geometry. And if you guys don't know, you always just pick one and go from there. So there's some geometry. And we're going to see if we can get a toolpath. Now, we are getting what looks like an error, to which is no toolpath whatsoever. So right off the rip, this is the great thing about Fusion. Again, I can't stress this enough, is I love the fact that when there is a problem, at least it gives you some clues as to what to change. So a lot of people overlook this, but as you're going to see, it's going to tell you right here in this line is the given lead parameters would cause a collision. So again, if you're new to Fusion, sometimes it's easier to jump somewhere and turn off things like leads and transitions so that we can at least get the blue lines on the part. Now, as you guys can see, we do have now those lovely blue lines on the part. However, something that I'm noticing here, and we're going to go ahead and do a little section analysis of this. So again, we're going to go up to inspect here, section analysis. Now, we could pull off the back flat of our part. I'm actually going to pull off the flat inside my part. And then I'm going to bring that forward just a hair. Now, knowing that we did have that 0.075, I could go 0.75 divided by 2, which is the width of my slot. And this now makes it so that I can evaluate or see what exactly are those slots doing. Now, this is interesting because initially when I saw this part, I made the assumption that we were going to need to wrap a toolpath around the cylinder. And that's not the case here. So again, this is the fun of Fusion and being able to evaluate things. Oh no, am I frozen? I am frozen. Is my screen frozen? It is not. Give me a sec, guys. I've had this in the past. I'm going to go ahead and kick my camera off, possibly back on. I may have to come back and restart something here. So give me a second here. So 1 second here. We're going to go ahead and throw you guys up on the, in the meantime, in case you guys wanted to know, in the next couple of weeks, we are going to be making our way down to Florida with a none other than great road trip as normal. Should I turn myself on this screen too, so you guys don't have to see that beautiful mug of mine? But what you guys are seeing is we do have that ability that if you guys are looking for some on-site training or want me to stop in and see you along the ways as we pass down through Chicago, moving down through Atlanta, Georgia, and then ending up in Florida. Again, in about 2 weeks, maybe even less than that, we'll be taking off and heading that way and coming back up. So a few more moments here, guys. I'm going to go ahead and restart a few things. Now, I'm going to kick my camera. Yeah, we're going to go ahead and just leave that beautiful face off. We're still going to get back over here. It's all right. What's the worst that can happen? So Steve is telling us that it can be wrapped. However, it really doesn't need to be wrapped. Now, the importance here is going to be is we are either going to need an end mill that is going to stick out long enough to reach all the way down to the bottom edge, or we can actually pivot to use what's called the trace toolpath. Now, the trace toolpath is great because although it's in the 2D section, it actually works like 2D contour, but allows you to follow different Z heights. So if I go ahead and go 2D trace here, we're going to go ahead and give it our curve that we want to follow, which is going to be that lower chain again. And then from that, we're going to go ahead and hit OK. And of course, as you guys may or may not be able to guess, I failed to use tool orientation properly. So let's fix that. So again, we're going to go to our tool orientation. We want our Z axis to point upwards. We could use the edge or one of the ends of the cylinder. And just like that, our tool is now coming in from the top and tracing around that profile. Now, something we do have to be aware of here, if I can get looking at it, trace by default is actually looking at the fact that it is going to follow the center line of the tool. And we're going to need to turn on our cutter comp. So go left, of course. And now you can see we actually have our tool path going down and around and coming back up to create that profile to cut the slot. Now I'm going to reorder this a little bit because if I go back in my timeline, as you can see, Steve has already gotten a lot of his tool paths in place. And if we hit F8, which is the hotkey, get this section analysis out of the way, we can then update our CAD information. And just like that, you're now seeing that we are milling that slot. Now, again, just like anything in the world of 2D, usually you want to have a little bit of a breakthrough. So we can go ahead and add that in. And what you're going to notice here is in the trace toolpath for heights, you don't have contour, selected contour, right? So we're going to jump to the passes tab where we can actually set an axial offset. So axial offset is going to work the same. We're going to go ahead and say minus 0.05. I feel like every time I go in and punch that in, I'm usually backwards. And in this case, I am not. So as you can see, if I was to simulate this toolpath now, again, props to the Autodesk team for the simulate with GPU. We could go ahead and bring that tool down. Again, we're going to go up, over, and back the other way. Now, as you're seeing me do here, we are still plunging into the part. So something we might need to do, and I don't know if it has it, is we do not have the ability to ramp down. So again, this is one of those scenarios, although you could do a lead in and lead out, we cannot ramp that tool down to be able to cut that groove out. Now, me personally, if I was running something like this, maybe I'm doing 10, 15 parts, I might just hit this with some multiple depths and treat it like a pocket clearing type of situation. So again, as you can see, you could go ahead and set your multiple depths relatively easy, and then you're making multiple passes in there. Again, just kind of a high feed machining scenario. This again is one of those things that based on what you're trying to do or how you're trying to remedy and solve this issue is utilizing something like 3D contour might actually work better, or not 3D. Actually, 3D contour might not be too bad, but not wrapping the toolpath as I initially did. Again, we're still going to need tool orientation here because we want our Z up. And what you're going to see in this example is going to be the fact that this is actually going to sit flat across that whole part, versus following and trimming on the inside of that cylinder. So again, what I would like about 2D contour is we could turn on ramp, and then just like that, we're now zigzagging down and ramping into that part profile. So let me know, Steve, in chat, does this look like it's going to work for you? Again, guys, I'm going to go ahead and jump over, and I'm going to see if I can't get my webcam to reboot one more time. Give me a sec, guys. It looks like NVIDIA broadcast is getting me. I'm going to go ahead and force restart that and see what happens. I used to have this problem in the past, and I think it was remedied when there was a Windows update, but since then it has come back to haunt me. So give me a few seconds here, guys. Again, if you guys have any questions, feel free to throw them in chat. Let me know what you think. Do you like what you see so far? Do you have any questions? And we're going to go ahead and see if we can't get this rebooted. Ash Designs with a question. Hey, Phil, I'm wondering if it's possible to lock the B axis at a certain angle while spinning down a cylinder part, like a rotary parallel. Yep. So there is a way to do that, and I'm going to show you guys how to do that here in a minute. Let me see if my camera is back up and running. You guys let me know. Am I still frozen? Of course I am still frozen, but I have a secret weapon. You guys are going to have to deal with my beautiful face. And now you can see my lovely flower background in my office. We're going to go back and see if we can't get normal back. There we go. We are back. All right. Now we can get back to our screen share. I can turn my lovely face on all these slides. Again, guys, at any time, if you guys have questions, throw them in chat. Let's get back to the old screen share here. Steve, I see you out there. I need to redesign the slot as it is being done on the lathe. Pocket is designed wrong. Okay, and we could remedy that real quick. Is what I'm assuming you actually want on this is, let's see what you got going on. You did a pattern, very beautiful. You did a straight extrude. Now that's not the case for what you need to be doing, but we need to wrap said slot. Now I am going to take this slot, and we're going to go ahead and double check your sketch here real quick. Looks like you're utilizing a line to hold this on center. And I'm actually going to break this a little bit more than I expected. There we go. Let's get this dimension out of the way. And then what I'm really looking to do is move. Yours truly is having some problems here. We're going to remove this guy. We are going to get our body out of the way because I think it's going to work better for us. There we go. Square up to our part here. And now with that, we want our slot to probably be a little bit off of center because this is going to wrap around our part, right? So I'm going to go ahead and throw in a construction line on this guy. Maybe. Man, I'm just not having luck here. Oh, I got 3D sketch turned on. Guys, that'll always cause you kinds of problems. Let's get 3D sketch turned on. Let's go ahead and do our normal sketch now. And we might have to back this up a little bit further because I may have butchered this long before. We could go ahead and try to wrap this. I don't think it's going to wrap where it sits. And I don't want to bore you guys to death by having to go in and make a bunch of changes. But what we're looking for is under the Create tab. It's called Emboss. Now, we're going to go ahead and revert our position back because, of course, yours truly started moving things around. But we want to take that sketch profile, and we would like to wrap it around our cylinder. And this is what I was worried about, is I did know that we were going to get an issue because that actual slot is down on our part. So what I'm going to do is I'm going to go ahead and start with a fresh sketch here real quick. And I'm going to do an offset. Actually, we won't need to do an offset plane. It'll be all right. There we go. We're going to sketch on that flat. Apparently, I keep moving stuff around. I'm going to create a brand new slot here, center to center, just to be safe. And now I am doing this off to the side, guys. So just so that you're aware, if you're trying to do this at home, that is what's going to happen. We're going to go, what is that? 0.75 technically divide by 2 because we are radius. And of course, it jumped out in the middle of nowhere. Try that one more time. Maybe my math is just way off today. Point. Let's just go, we're going to go 0.62. Oh, because we're in millimeters. Do you guys see this? You guys see what you guys put me through? This is why I get all the fancy support tickets and all that fun stuff. We're going to go back to inch. There we go. And for those of you wondering, yes, at the end of the day, we could have very easily went in and actually just said IN versus the other 0.075. There we go. Actually, it's 0.75 divided by 2. Give her a second to update. There we go. And now we can get this guy moved semi to where that slot is going to go, right? So again, using the emboss feature, you can't be on center line of what you're doing, which is why I've created my sketch down here. Now we should be able to get the emboss feature to work. And in this case, we're going to go ahead and do a deboss. And maybe I'm crazy in my thinking here, which wouldn't be pretty normal, right? Is that this is not working to my advantage when it should be. And we may have to make a few more adjustments, but I don't want to get too caught up in this. Again, the emboss feature works great. I'm probably doing something wrong. It's usually on me, as you guys know. We're going to go ahead and jump to another problem here, and we're going to have to see. So we finally have the dark theme. Travis, 100%, the dark theme is completely available inside of Fusion, if you guys didn't know. Now, this is a personal preference thing. I'm not really a big fan of it. Maybe I'm just stuck in my old ways. But how you can set that up is I'm going to go into my preferences, and I'm going to go down to either Fusion, or you could, I apologize, dark blue, or you could do match device theme. So as you guys are going to see here, as soon as I hit apply and OK, I am now officially in what is referred to as dark mode. And just like that, you could have your display and your toolbar and all that fancy stuff now dark. Again, putting this out to Autodesk, it'd be nice to see black outlines on all the icons, I think, or white outlines, something of that nature, so that they pop out a little bit more. So let's go ahead and shift gears. We're going to go ahead and open another part here. We will come back to this at some point today if the questions slow down, of course. We got to get back into the right folder. We're going to jump into this next part. Actually, it's not going to be that one quite yet. We're going to go, let's go 763, is it? Yep. So somebody sent me this part. This is another really fun part, but if you guys can see, we have these green surfaces inside of here that they are wanting to 3D machine. Now, for those of you that don't know the great world of machining, if I go in and I actually do a accessibility analysis from the top, what you guys will notice here is anything in red there is considered undercut, right? So if I'm looking at this from this angle, I would need a second operation to come in from the side, but it gets worse than that, because if we did another accessibility analysis from the left here, or the right, left, the side of the part, as you guys are seeing, we now have undercutting back the opposite way. So this feature is a very hidden feature when it comes to machining. Now, there's not going to be any good way to really do this. We are going to have to do this across two setups, or if you have a 4th or 5th axis machine, it's going to be much more beneficial. But I'm going to show you guys how you could get some tool paths down in there. Let's go ahead and jump into the manufacturer section. I need to grab a drink here. Also going to go ahead and check the ticket system here real quick for you guys. Want to make sure that nobody has sent us any tickets outside of the ones that you guys have already hit me with. So let's go ahead and start doing some of our setups. So again, we are going to have to do this with two separate setups, or you're going to need a 4th or 5th axis. And what you guys are seeing me do here is nothing more than setting my X, Y's, and Z's. I'm probably going to put this on a UMC type of machine. It'll make my life much easier. And just like that, fixed size box. And it looks like we are getting some pretty wild rounding on this part. Now, I never check my models, but for some reason, there's occasionally times when there's a million things going on inside these files. So what we're going to do is we're going to jump back and make sure we define the proper model, as you guys can see. And then for the sake of this part, we're just going to go ahead and round up by 0 as if it's coming out of a squared up block of material, right? This is just going to make everything we do at this point much easier. Again, I'm going to make my life easy, and we're just going to 2D contour. And I'm going to utilize probably a 1/2" end mill. If you guys don't know, I love the 1/2" end mill. Tends to work quite well for a lot of things. And the geometry I'm going to use is the upper rail. Now, I'm going to put this out there in chat, guys. Why is it that you think I'm going to use this upper edge to define my boundary versus any other edge on this part? And I am going to now just go ahead and define a different lower height. So as you guys are looking at this, we're going to go ahead and go no lead in, lead out. Again, cheating and using ramp. But as you can see, I'm now zigzagging down inside of my part from the top. If this, again, was something where we're starting to look at and discuss utilizing a 4 or 5 axis machine, this is where I might pivot 2D adaptive clearing. Let's say, for example, we switch to a smaller tool. I believe I have a 1/4 inch tool around here somewhere. We do our tool orientation to the side. Again, pocket selection. As you guys are seeing, I'm picking this upper chain here. I'm not utilizing a lower chain. And again, the reason why I'm not doing that, if you guys are wondering, is because there is no connection across that bottom chain. Same with my top view, this upper chain, upper rail, it would have actually extended out under that overhang, causing some more problems. So again, utilizing sometimes a different chain and manually setting your heights can make all of the difference. So again, we need to go to a certain depth, which is going to be this guy here. And that is going to achieve us a roughing out from the side. Again, this is where we could go in and derive straight into a 2D contour. And basically what I'm going for is just to get you guys a nice clean kind of pocket through the part. So let's now talk about how we're going to achieve those green surfaces, right? So again, this is where section analysis can be your total friend. So we're going to go in, I'm going to go ahead and section analysis right here. And just like that, we can now see our inside corner as well as the surface that I failed to highlight in green. Now, there's only a couple of tool paths out there that can actually utilize undercutting. Now, for me, the number one that I like is the steep and shallow tool path. So the question was, can I do this with a lollipop style cutter? And the answer is yes. So again, I'm going to go in, we're going to select a lollipop style tool. Again, the Fusion library has quite a few good ones out there to start with. Keeping it easy on you guys. I see a lot of people go in and they try to build a tool and then make a tool path. If you can find something close, it will help you make a good tool path to which then you can modify your tool. So as you guys can see, we have a 1/2 inch ball or lollipop style cutter. Again, we have our geometry section as always. I'm going to jump over to the passes tab because the moment we swap out to steep only, we're going to get the option to machine undercuts. And with that, we can go ahead and let this do whatever it's going to do by default and adjust. Again, guys, it is very important at the end of the day to just get a tool path on your part. Now, as you guys might be able to see, it's my big head in the way, probably is. We are swiping down and underneath. And if you notice here in my stock model, I am now touching that wall, right? So again, this is one of those things that, one, you saw me do very little other than tell it that I want to allow it to undercut the part, but I can go back at any time and now adjust my boundaries. In this case, my boundary could be based on a silhouette. I would like to stay inside that silhouette or maybe tool center on that silhouette of my part. And now we should transition into machining down underneath inside those walls. Now, if we wanted to get more technical than this, we could, of course, reduce our surfaces. We could actually sketch a boundary profile. There's a lot of different ways to go about it, but I think some of you are starting to see the value of being able to loop down and around to get that undercut type of motion. And again, I'm going to go ahead and turn my stock off. Be much easier for you guys to see. Now, if you have toolpath trimming, this is a whole nother scenario because, again, you could toolpath trim, which you would have toolpath trimming for the record, because it comes in the manufacturing extension. So as you guys have seen there, I've actually trimmed that the wrong way. We only want to do what's inside that area. Again, I could actually trim this one more time on top of it. A lot of people don't realize you could actually double trim things here. So we're going to go ahead and trim one more time. I would like to actually do everything outside of that area now. And just like that, we're only doing the wall, right? So again, getting that undercut area, we could remove this. We could cut this down more. We could, of course, go back and adjust that lovely polygon that we've made. Because now I'm realizing is, you know what? I really only need to be in a certain area, which is that little window undercut, right? So as you guys can see there, now we're undercutting that area and everything is set clean as can be. One other thing that I did see, I want to see if it'll work on this part when it comes to toolpath trimming. I'm actually going to untrim the backside here. But you do have the ability to use planes, and I think we tried this before, but you can't quite use... Yep, so you got boundaries, and okay, so we could do face contours possibly. And if I pick these faces... Now, the problem is, for some reason, is I can't grab this green surface here. And I believe I actually do know why that is, because I'm thinking in the wrong direction. So in typical fashion, yours truly is having a problem with thinking inside or outside the box. Now, the real thing that we're going to have to worry about, I think we are going to need a boundary offset here because, again, this could be based on center line of the tool, but we're going to see what happens. We're going to go inside, see if we get any tool path, and we don't. So I would need to add in, more than likely, the radius of the cutter at a minimum. Let's just go 0.3. And just like that, again, utilizing different things inside the software. Again, this is all toolpath trimming, guys. I would still need to possibly come in and trim it from the side. As you guys are going to see here, we go ahead and throw another trim on. Boom. I guess I could actually trim this again, second time through. We're going to utilize boundaries, face contours, because, oh, we cannot, because we are not looking in the same direction. So again, toolpath trimming is great. We would actually have to go based on which way are we, set up Y. And let's see if we can do it this time. There we go. So you can, look, even yours truly learns that in the great world of Fusion, they have thought about just everything. I needed to change the flatten direction. And again, what you guys are seeing is that little gray box that is hiding behind my head. Is we are going to now trim across the part that way. Again, I'm going to go ahead and throw in like a 0.3 boundary extension. And from that, we should get a pretty good trim. What's meant by silhouette? So on the silhouette side of things, real quick, let me go back here. We, of course, need to keep whatever is inside that area, guys. But a face contour, when we pick those face contours, it creates a boundary around a silhouette of the part. A silhouette, in theory, if you've ever seen it, is the old-timey photos where they do like the side profile and it's just a black and white piece of paper. It's a silhouette of whatever your shape or profile is. So again, guys, as you're seeing me do here, some more trimming, some more fun, just to get in and get around the inside corner of that part. Now, again, same thing. If it was me, I would be focusing on steep and shallow. Now, if you didn't have the machining extension, you, of course, one, you obviously, I don't know why you wouldn't have it unless you just ran a 2-axis lathe. But if I go in and I do something with 3D contour, this time we're going to go ahead and do our tool orientation. We go off the side of our part this time. I am going to possibly set a boundary. Again, silhouette of our part, tool center based on that. And then with that, 3D contour, I think a lot of people don't realize is 3D contour. You learn this lesson the hard way like I did, where I had 2 mold cavities that stacked on top of each other and I didn't pick the lower one. And what do you think happened? It wrapped around and went underneath my model. So as you guys can see, again, 3D contour is wrapping around and undercutting that profile from the side. Again, I'm going to go ahead and hit F8 here. And you guys are starting to notice that right there inside my part, we're starting to blend this back and forth. Now, ball size, additional settings outside of that. Let's get our analyze turned off. Luckily enough on this part, for some reason, they didn't actually fillet anything around the underside of this face as well. But if we go in and we do our simulation, we should be able to see this. So there's our tool path coming in. Again, it's going to start very high. We could adjust this with our heights tab, of course. And what I'm doing, again, this is a pro tip for you guys. If you click on screen and drag left or drag right, you can speed up or slow down your toolpath. So instead of pushing play and trying to make a guesstimation on what's going to happen, you're noticing in real time, I'm just dragging my mouse across the screen. And at this point, I think we are starting to undercut in that surface. We are. And if we get a little bit further, oh yeah, we got that blue starting to disappear. And let's go back just a little bit further. Might have to go just a little bit further than that pass. I'm trying to get you guys some good examples here. I might have to turn my accuracy and stuff up. But again, this GPU simulation is quick at the end of the day. And you'll notice that we are getting green surfaces versus the blue surfaces. Due to tool ball diameter, as you guys can imagine, we can't quite get fully at the top or the bottom, but we are getting exactly that. We are reaching this from both ways to more or less get underneath that actual area and cut those surfaces. 100% Norbert, I love the suggestion. Can this be done with like 5-axis positioning? It could 100%. So again, I wanted to show you guys this kind of method here because, again, if you did not have a 5-axis and you wanted to set this up in a 2-setup, 3-axis kind of configuration, again, I would still need a second setup, guys. I didn't build that all out, but I could go in as being suggested is, what about if I was to do something with like a small 1/4-inch ball end mill? Still the same scenario at the end of the day is we could go in, we could pick our tool path. You could go contour. Maybe you're going to go parallel. This is up to you. But based on that is I'm going to go ahead and swap out to a much smaller tool. So again, we'll go into our default library. Let's see what we have in the shop crib. Ball end mills, 1/4-inch ball end mill. And we are going to need to swap the holder out on that. Give me one sec here because, oh, those are all 1/2 inch. Has this got a better holder? It does not. Let's edit this tool here real quick. And we're going to go ahead and set our holder to hopefully stick out a lot more. Or if you guys didn't know this, we could, of course, add like an extension shaft here. So we'll go ahead and add a couple pieces. Just say we have 2 inches or so. As you guys are seeing, I'm butchering this pretty good. Let's delete this one. There we go. Let's add that back in. And let's say we had a 4-inch extension. And then we are going to have to change our stick out as well. So this is going to be probably like a 4-inch stick out. Overall length is, of course, going to have to update. This is a little bit of the finickiness side of Fusion. Now, hold on, guys. I'm going to fix this, I promise. I pushed in the wrong diameter. My fault, okay? So again, let's say 0.5, 0.5, and the height is what needs to be 4. And just like that, you guys can see we now have an extension or a shaft. Again, you could add taper to this if you guys want it. Let's say it goes from 0.4 up to 0.75. In this case, again, I'm upside down. Good news is in real time, we could see how badly I'm butchering this. So again, now we should have a tapered kind of extension on that tool. The reason why we would want to taper on an extension tool like that is because, again, we have a lot of tight clearances in here and we're really just trying to get down in there to machine those surfaces. Now, a trick here is going to be the fact that when I do my tool orientation, a lot of people don't know this, but if I'm looking at something like here and I'm like, you know what, I think I could do a lot with a tool at this angle, I could actually just hit align to view and I could turn on accessibility analysis. So again, it's one of those things that you have that ability to turn on different tools inside of the software. Get my section view out of the way. And just like that, anywhere in red right now based on my view is basically undercut. So again, these are some neat things to be able to help you guys build out a much better and a much cleaner tool path. So again, we go ahead and hit OK, and then we can adjust from there. So if you guys are joining us now, I see a lot of you coming into the chat. If you have questions at any time, feel free to throw them in and ask away. I'm going to go ahead and make a couple adjustments here. Like, for example, I'm using scallop for some reason. So let's go back in there. Let's go ahead and do our align to view. And let's try that one more time. Again, what we're looking for, as always, is to get a tool path on the part. And I think we need to be a little bit more steeper here, or because yours truly's graphics settings, let's see what kind of visibility do we have. We are looking for camera, ortho only, and then let's see if we can align to view. There we go. So that ortho with perspective faces will get you from time to time. And again, we can narrow this down and trim it out, or you could use things like, again, I want to do a selected boundary this time. You guys are going to see with this selected boundary, we now have a window of that area based on our view, and we will need to adjust this more and more. There's no stoppage or no change that, again, based on your view, all over again, we could do face contours, this one, and possibly this one. Again, what we're looking for is a boundary to limit our toolpath based on the angle at which we're looking. So again, you do have some undercutting here. I am using scallop. Scallop is not an undercutting kind of toolpath. So I can quickly derive out, go to another 3D milling toolpath. Again, depending on what you guys are going to use or what you want, we're going to go straight into 3D contour. Again, 3D contour has the ability to do some undercutting. Now, if it was me, you're going to spend a lot of time basically angling and adjusting and getting in there to do whatever is needed. This is also one of those scenarios where we talk about maybe, again, you would need the machining extension, but if you go to something more like steep and shallow, same thing again, steep only. And then my recommendations would be is you could just go full 5-axis contouring. Now, why you may or may not want to do this is all dependent on part quantity, how fast you need to get it done, what is the end goals of what you're working on. So again, any questions out there? I am going to go ahead and check our ticket system to make sure nothing has come through. Does anybody and everybody have questions? Feel free to ask them. If you're watching this at a later date, feel free to throw them in the comment section or use the email down below to message us directly. So let's go ahead and pivot. I'm going to go back to this part because I really want to get that wrap toolpath to work, and I have a couple ideas of why it doesn't work. This is pretty standard for me. It's on me, guys. It's always on me. So what I'm going to do is I'm going to remove my sketch. I'm going to do the wiser thing this time, which is do an offset plane, or even better, tangent plane to that inside cylinder. So as you guys can see, I've now done a tangent plane to that cylinder. I am going to 100% steal this sketch here. So we're going to create a new sketch up top. I'm going to do the old P for project, and we are going to project the original slot. Again, as you guys can see, I now have that lovely purple color up top, and that is going to be what we're going to wrap at the end of the day. So what you're going to see me do is we're going to go back to that emboss tool, this guy around a face. And you know what I might be doing? Let's do this. Let's undo tangent chain. Let's just grab that. There we go. And then we're going to actually pull that down into the part because we want it to cut. And just like that, we are now cutting that slot, and it is wrapping around our part. So again, as if I turn on, of course, I'm not going to have our analyze anymore because I went ahead and deleted my features. So let's add a brand new, actually, we're going to jump back over to manufacture because I do have the one that I wanted over here. And I believe I actually put that taper in the wrong spot, but I think we're going to be okay, right? So again, my cut plane is going to be based on the surface, 0.075 divide by 2 to get us on center. Actually, this one's going to be negative because I picked the wrong, divide by -2. Maybe not. Divide by 2. Negative 0.75 divide by 2. Hey, man, I tell you what, it's been one of them weeks. How you guys feeling out there? How you guys doing? Any questions? So again, we now have our slot. Our slot is actually cone-shaped to the center of our axis, and then we can utilize some things with that. Can you cut the slot without the tapered walls? So Veruca cut the slot without the tapered walls. We did do that originally when it was a straight-on slot. So from that, as you're going to see, we're going to go ahead and utilize a couple of different toolpaths. Now, this is where I was saying that if we were going to wrap the slot, again, this is where it points to center. Again, we're going to do our wrap toolpath around a cylinder. I am going to select a contour for wrapping around. And of course, we're going to get an error, and that error is going to be based off the fact that we can't do the lead in, lead out. We already know that. I can ramp down a wrap, which is kind of nice. Now, the real problem with this scenario, and we're going to go ahead and jump back over to simulate. And we are going to crank the accuracy and hope that my computer doesn't explode. So what I'm looking for here is that when we cut down that surface, one thing you may or may not notice, and now it's not going to be very noticeable on this part, but I want you guys to be aware of this, is center line of this tool diameter points to center of the rotary axis. Now, the diameter in the corner of this slot, or the width of the slot, is greater than. So by picking the lower chain, it is allowing that toolpath to move out further. If I pick the upper chain, it will bring the toolpath in. However, your slot will never dimensionally actually check out properly with a wrapped toolpath. This is why instead it would be better to do actually something like advanced swerve. Again, advanced swerve allows you to do fourth axis. We're rotating around Z because we are on a lathe. I can go ahead and pick my wall surfaces here. I will have to turn that section analysis off so I can grab the back one. Again, this is another way to approach this and another way to sit down and machine it. Now, I personally, when it comes to the setup of swerve, there's a lot of ins and outs about it. I think we are also going to have issues with our lead in, lead out, which is why you're seeing me remove those real quick, because we always want to get blue lines on our part before anything. So what I'm going to do is I am going to avoid using surfaces. We're going to go the good old-fashioned guide curves, upper and lower. And we're going to see if we can't get that tool path on there. Again, let's just double make sure that our tool is the correct size. Now, there is another thing that I'm almost certain is haunting us, which is our shaft and holder clearance, like always, as well. So we go ahead and take a peek at that tool. We do have quite a good amount of stick out and everything. So I'm going to just go ahead and zero these two guys out and see if we can't get closer than that. In the meantime, if you guys have any questions, throw them in chat. I see Tim out there with a question. Any tips on making the other hand version of a part that is already programmed and proven? Run that by me one more time, Tim. Making the other hand version. Oh, okay. Like a mirrored version of a part, right? That's what you're referring to, Tim? I'll give you a few seconds in chat. Again, guys, questions at any time, feel free to throw them inside of chat. You know what we could be missing actually is a floor surface. Let's go ahead and add a floor surface in. I feel like the floor surface has haunted me for the last couple of weeks. Spiraling down a cylinder part. That's right, Ash. I completely forgot about that, but I got you, buddy. I got you for sure. We could do that. So Ash wants to know about spiraling around a part. In this case, there is a lot of options when it comes to that. Now, keep in mind what initially I would point you guys to if, and this is a big if you want it to stay perpendicular to the part, right? You could do something like rotary parallel. Now, rotary parallel at the end of the day doesn't have something like tool orientation. So you can't tilt the tool and wrap the tool around the part. Now, I'm going to use this as an example, but if I wanted to, in this case, I could switch to something more like geodesic. And again, this is where we could play that game of pulling our end mill. I'm going to go ahead and grab some type of ball end mill that I have out here. I believe this guy will work, a little bit large, but we're going to go ahead and we could base this off 4th axis or 5 axis. And with that, we can actually change out and say lead and lean. Again, if this is dependent on your machine, we could also go in and say tool axis limits. There's a lot of ways to achieve this, but let's go ahead and say we're going to go 4th axis around setup Z. We're going to leave lead and lean alone. And then from that, my geometry is going to be whatever surfaces you plan to machine, right? So again, we're going to go ahead and grab these couple of surfaces. I'm going to swap out to blend. What blend will do is basically give me a consistent kind of step over versus a scallop type strategy. So Tim, yes, mirrored. I had some small pieces. Yep. And make left hand, right hand. We'll go ahead and visit that here in a second. So first and foremost, did we achieve wrapping a tool path around a part? And the simple answer 100% is yes. So now there's a lot of different ways where we could do what would be referred to as like a fixed angle, right? So one way to do that would be is we could actually say, I want to lean because we want the tool to lean left and right. And we could throw in either a positive or a 45. There's also the ability to utilize what would be referred to as a tilt angle, right? So again, as you're seeing, is there's a couple of different options to utilize. for setting that angle. So I'm going to go ahead and slam in a 45-degree tilt angle. We're going to see what we can come up with. So again, we're going to give this a few minutes. As you guys can now see, I am at a fixed 45-degree tilt angle. And of course, if we go in and do the good old-fashioned simulate, we're going to hit play on this one. Maybe. I think my Fusion just froze. We're going to give it a second before I anger the Fusion people. Oh, it's because yours truly cranked his comparison way up, which they tell you is a big no-no when you're doing simulation. I'm also doing machine simulation when, you know what I need to do? Here's a tip for you guys. You know, you guys can reorder these things up here. So you could actually click, drag, drop. In my case, I never push the generate button here. Let's unpin that guy. Make my life much easier. And honestly, I also never use setup sheets. So I could unpin that one as well. Now we got what I would say is the perfect workflow, right? Simulate it with the fast GPU simulation so that we could see if there's any big problems along the way. And then from that, we could jump over to machine simulation from there. And I think I'm still out of sync here. There we go. And as you guys are seeing, can you not do, let me regenerate this file here real quick. Can you not do fast GPU simulation on the lathe? I think we might have found something. Or we've got a million errors in here. We'll try to simulate just the one tool path. So again, we're going to go back up to simulate. And as you guys can see, actually 100%, I don't think you can do fast GPU simulation on a turning part. But as you guys are seeing here, let's go ahead and change this out. Let's make our tool stay stationary. Kind of like if you had a B-axis head on the lathe is what we're going for here. And again, this is going to look funky because our tool is now rotating around. We actually swap that back out to model. It'll be easier. But yes, just like that, we utilize tilt and geodesic to basically set a fixed angle, or in this case, a B-axis rotation, maybe even, actually, I take that back, because the question was, can we actually tilt the part to the side and then spin around that part in simulation? And that's 100% correct, we can. So again, if I did a brand new setup here, selected a machine, you guys didn't catch it, we went ahead and built a VF3 on Workflow Wednesday, utilizing adding our TRT system in there. But let's say our Z-axis was up on this part. And as you guys know, I'm a big fan of from proceeding setup, always utilizing continuous rest machining. There's our part sitting on our machine. We'll space her up in the air a little bit. And now, of course, we're going to go ahead and move our geodesic down. So a few things I'm going to do here just for the sake of this part, getting our cycle times back down, getting a clean solid going into the second half, and then we're going to regenerate that toolpath and see what we get. Now, again, this is a TRT system. The question was about B-axis. I believe this is an AC configuration machine, but the concept is still going to be the same. So as you guys are going to see me do, we do the simulate with machine here because we have a machine, of course. And now we can actually utilize tilting, but of course, now I'm backwards again. Once you change one thing, everything goes downhill. So we're going to keep the machine base still. We're going to tilt the part, and then we're going to see that part actually spin around center at a fixed angle. Again, the only thing I did here is I used the tilt part when I set up lean and lead, and I forced it into a 45-degree angle. So I hope that answers that question out there. And with that, I see more and more comments coming in is issue with the lathe this morning. I'm not sure if it's a post issue or a bug. When doing undercuts, if unused can cycles is started and the undercut too soon, when I long code it, it works right. Travis, I would have to get a little better example and see what you're talking about. So, when doing and undercuts, Travis, I don't know how you're using can cycles and undercuts. That would be something I would need to see a little bit more information about. Yeah, Ash, no problem. I would be happy to explain the difference between the three options. So, as you guys can see, is I do have another video out there. It's funny because I made a Facebook post. I don't know if you guys caught it, but it was about the fact that I was asking Google Gemini to write up some descriptions for me, and then it recommended my own video. And that video is based off the fact that we explain 5-axis control. It's an amazing video, by the way, not to toot my own horn, but when it comes down to 5-axis control inside of Fusion, you have the ability to either lead and lean. Now, sometimes you do have vertical. Vertical is self-explanatory. Stay vertical until the holder gets too close, then start to tilt, right? But lead and lean allows me to actually manually override control of tilting the tool based on the surface at which we're machining, right? So when you guys hear me say perpendicular, parallel to the surface, I'm driving the toolpath tilt off of that. Now, getting a little bit further down here, as you guys can see, is based on lead. I can tilt the forward or I can tilt back on the tool. Now, usually you don't want to cut up, as in down milling on a tool. So usually you're not leaning back. You could lean forward, very beneficial. Again, if you're trying to run in a straight line. The whole goal here is to basically get off the tip of the tool. Same with the lean angle. This is where we're talking about tilting left and right, right? You know, you have your pitch and your yaw and any other kind of configuration, but that's nothing more than controlling it to say, I want to lean the tool. Now, for those of you that haven't seen it so far, we've tilted and we told Fusion, just fix the tool at 45 degrees by using tilt. Had I gone in and actually say, lean the tool at 45 degrees, let's go ahead and see here. I'm going to go ahead and turn my tolerance up. As you guys know, it makes for a very fast tool path. But what can happen based on that information is it could lead our tool, lean. Am I in the right? We are in the right. Okay. Is when we simulate this, is it is going to lean the tool against the surface versus using a fixed angle of the machine, if that makes sense. As you guys can see, we're coming down on this part. And now it did put us at perfectly 90 degrees. So I might have to do a little bit more adjusting to this, but that is what you're seeing as we machine across this. It went back to perpendicular on that surface, and we are getting a little bit more jumping around motion. Now, what I'm really trying to force for you guys to see is in the event that you're doing something like this, is if we actually went to something like 15 degrees, you could actually get more or less tilt on that toolpath. So for some reason, and I actually know the reason, yours truly can't, I mean, I'm using a 4th axis only toolpath. That's why I'm not getting 5-axis machining. So if we go 5-axis now, and we go back to lean at 45, again, what I was trying to convey to you guys is Norbert's question was he wants to fix and basically spin your C-axis. Well, obviously, when I say, you know, fixed angle, it can't lean on a 4th axis. So going to 5-axis and leaning will give you guys a much better idea of how this is going to work. Now, this is the dangers of it, right? So I went positive 45. And for those of you that are new, just bought a 5-axis machine, as you guys are going to do, I'm going to go ahead and go down to my tool path so that we don't have to keep simulating this. But if I turn on tool axis in my options, I can now see the angle at which that cutter is cutting. So again, now we are dealing with a 45-degree lean. And where it's going to get tricky is I don't think we have the right tools for this. Actually, you can start to see this in here. And I'm going to simulate this because you'll see it more. But it's trying to maintain 45 degrees of the tool. So when it wraps around this little profile here, it wants to tilt even further. Now, before we simulate this, of course, I'm actually going to swap out from positive 45 to negative 45. This will actually point our tool more in that fixed angle as questioned. But as you're going to see when we simulate this in a second, it's going to actually tilt up much more vertical in a second. So with that, let me go ahead and jump back over. Ash, let me know, is that kind of explaining it for you? I got to get my machine sim spun around here. And again, what we're going to see here as we run this part is at some point, we're going to actually see quite a bit more tilt on the machine. Again, pro tips. We got tons of pro tips for you guys. Is if you didn't know this, you could actually populate in the info tab. You can look at more or less the machine position and angles as well. So as you'll see here, currently our A axis is at 45 degrees. That's behind my head, isn't it? I should get out of the way. And eventually you're going to see 45.3. We've now adjusted more. We're now at 65 degrees in our A. So again, lean and lead are always trying to go off of the surface. Tilt is basically at a fixed angle. So Ash, great to see that cleared that up for you. Travis, let's get back here doing undercuts, doing an undercut. If used can cycle, it starts the undercut too soon. When I long code it, it worked right. Travis, I'm still going to need some more information on that particular use case. So I see more of you coming in and going, guys, at any time, if you guys have any questions, anything in particular that you want to see, anything that you really want to go and see me dive deeper into, any problems you've had this week, any other issues outside of that, I'm here for you. But I am going to jump back to Tim's question about a left hand, right hand kind of scenario. Now, it can be painful if you have to machine a left hand, right hand kind of part, because, I mean, one way you can cheat it is you could take your toolpaths, and if you go up to setup, you could actually do a new pattern. And with that pattern, there's what's called mirror pattern. Now, by turning off keep original, you can actually reverse everything on your part. Now, the problem is going to be is the plane that you mirror across, you really have to pay attention to what you're mirroring across, right? So if I mirror across right here and I hit OK, what's the problem is going to be is my toolpaths are far over here to the right. However, my work offset is still over here to the left. So in most cases, if I have to deal with programming a part that is a mirrored situation, I have a tendency more just to jump back to design. Again, I will just go up to create, mirror, pick what I want, go across the plane. Just like that, I now have a left-hand, right-hand version. So in my opinion, it's better to do it at the model/component level than it is to mess with the toolpath. Now on the toolpath side, why you also wouldn't want to do this, I'm going to simulate this for you guys. I think we can get away with simulating both. Would actually like to simulate just one toolpath, but I don't think it's going to give it both of them here. Yep. So what I'm going to do is we're going to do some Hollywood magic. If you guys didn't know, we're just going to duplicate one into another. And then what I want to do is remove a lot of this out of here. So let's see if we can simulate the pattern now. It's going to give it to me. It is not. Go back. Now let's simulate both of them. Probably should have made a much cleaner toolpath here. Let's fix it. Let's do this the right way. Flexion, top height. We do not need a ramp clearance of 0.1. And let's see what else we got going on here. Here we go. Quite the big ramp. Don't you guys think? Like there's two toolpaths in one, as if somebody double selected contours here. Let's see what's going on. Did I lose my bottom reference? I did not. Guys, we may have found a really good bug inside of Fusion. Let's see something. If it's not in the pattern, still looks like complete problems here. Oh, you know what it's? Might be. Let's see here real quick. I don't think it's our ramp, but it could be the ramp. It's definitely doing multiple step downs. And we don't have multiple depths turned on. So I think we just found a bug. But either way, this is still going to work for the nature of what I want to show you. So when I simulate this, and as you're going to see, is on this first part, pay attention which direction this cutter goes. Because right now we are climb milling up, down, and around our part, right? But when we go to jump out of our part and move over to the other side, which is going to be tricky because you guys, you're going to have to pay attention to the actual tool path. But if you notice, we're now conventional milling on the other one. And I can go ahead and turn on all the tool path. But again, notice how we're coming up the left side here and back down the right side, which means we're conventional milling. So when it mirrored, it literally went through and mirrored everything, right? So it's running your tool backwards. Again, can throw your tolerancing off. This is where like when I program mirrored parts or have to deal with left-hand, right-hand versions, in my opinion, I tend to set up programming my part with automation, utilizing things like templates so that I can quickly move from one part to the other. So getting back over there, guys, any other questions out there? Hoping that somebody can bring all of the operations with it. Yeah, the left hand, right hand type of scenario it's one of those things that, again, not the strongest suit inside of Fusion, because as you guys saw, is when you mirror the toolpath, it kind of throws everything off. Now, in my opinion, again, guys, you can build out quite a bit of automation to be able to automatically generate those toolpaths. This would just be an example from me to you, is if I would go in and do something like 3D contour instead of normal contour, you could actually generate kind of the same results based on, you know, again, silhouette, tool inside boundary. I want a large step down based on my tool. Again, a lot of things that you can get away with here to set up and machine, right? With that, I'm going to go ahead and jump back over here. We got another one. If you have a left hand, right hand, just program one and do the mirroring on the control. Only problem is climb milling will now be conventional milling. Yes, 100%. You would have to go in and start reversing tool paths and stuff like that as well. So again, just for you guys at home, you could, when you mirror this, you go in here. One, we're going to go ahead and turn off keep original. And as it's being suggested here is if we go in and see our tool path, if we were to switch from left to right, from there, we would also have to reverse our chain. Actually, we shouldn't have to reverse our chain. But if I was to simulate the mirror now, you'll notice that we are now working with the confines of climb milling on the mirror versus conventional. So this could be valuable or a complete pain. You guys will have to let me know. There is a few more tricks here. Is I could go through and do a compare and edit. And then you do have the ability to say, you know, I want to bulk update blank field. You will need to know what that field is, of course, which is going to be sideways compensation. I just want to double check it on 3D because I think it's now direction, right? So 3D, it's direction, but in 2D, it is sideways compensation. So again, you'd have to find sideways compensation, update your 2Ds, and then your other one, of course, would be, I can't even remember what it was. I've already lost it in my brain. I just feel like it's 10 times more steps versus setting things up the way you guys saw. Now, I'll spend a few more minutes on this because I want to show you guys a few things that I think people overlook when it comes to a left-hand, right-hand scenario. Because if I was in design, this is probably not going to be the best example because there is a lot in this part. Let's say let's pull up a new part. Don't save. I want to get a file that is actually built out the way I recommend. So we're going to go back to the good old-fashioned, I think I have something close here, the good old-fashioned 2D strategy. Now, for a lot of you guys out there, if you didn't know, what I tend to recommend at the end of the day is start with a blank file when it comes to your actual CAM side of things. And you could save that. In this case, it's going to be 2DS manufacturing. And of course, because you guys know me as the most organized person possible, Free Support Friday, we'll get it thrown in the right folder. And then, this is my recommendation, you're going to insert that file, which is going to allow you to keep it linked in case you have rev changes, in case you have customer updates. And it also prevents your guys on the floor from breaking or changing the original part, right? So now from that, a couple of neat tricks that you could do is before I get from left hand to right hand, if I needed something like particular pockets or certain features, this is where something as easy as doing offset surfaces could also be very beneficial to what you're doing. Because if I went in and actually snapped an offset of this pocket here, for example, I would have that as a quick reference later on. And what you guys are seeing is that is now that inside pocket area, which is technically a body that if I'm using model, I can auto-generate toolpaths from. The other side of that is that when I get to that point of doing my mirror, Again, this is the fun of this, is I could actually say, you know, I want to mirror bodies, components, whatever it is. I can take and mirror everything, right? So again, as you guys can see, I don't want to join. That could be a new body. I'm going to repeat mirror here real quick because we're going to do the component. Same plane. And I just want to get you guys an example here that you now have your original, you have your mirrored, you have your mirrored pocket. Again, getting back into manufacture, when I do my setup for my first part, my original model is going to be my part that I wanted to make. My new setup for the mirrored one, again, that part is now going to be the mirrored component I made. Of course, you don't want from preceding stock. And then when it comes to making those tool passes, I was saying is, let's say we go 2D adaptive clearing. You have that ability to do a pocket selection. Of course, you could manually pick it. Again, this is the fun of this, that you could use face contours, or if you're 3Ding, right? I could actually base my 3D tool pass off utilizing model, not the setup model, and then I could use that surface that we generated. Again, this is just an example. Don't get too caught up in this. This is just a neat way to rinse and repeat, utilize things like surfaces on your part to your advantage. As you guys are seeing, of course, there's a lot of other things going on, but that offset surface can be quite handy. There you go. Pavel out there with the tip, using a script that copies your entire setup and reverses the machining direction in all operations. So Pavel, I would tell you, man, if you're willing to share that script, I'm happy to possibly publish it on our YouTube channel or place it somewhere where people can easily download it. I can host it on our website. You're also welcome to throw it here in chat or also put it in a comment on this video. So as you guys are seeing, again, mirror X and 5-axis, also mirror C. Yep. So again, a lot of guys out there with the concept of mirroring are switching the axis directions at the machine. Cool. Any other questions outside of that, guys? Again, we are here for you. We're going to leave this open for you. If you guys have no further questions, I, of course, am going to go ahead and hit you guys with the typical, it's not what you know, it's who you know. You guys let me know. So again, I'm going to go ahead and resolve out some of these files here, close out some tickets. Any other questions? Going once? Going twice? If you have questions, feel free to throw them at us while we do our outro, because I'm always happy to come back and keep showing you guys stuff. But it's not what you know, it's who you know. You know Fusion Phil over here at jitcadcam. We are an Autodesk reseller. We are an Autodesk partner, or whatever the terminology is nowadays. We've also updated the websites on Autodesk's page to reflect all of this information. But if you guys are looking to buy Autodesk Fusion or want to move your Fusion licenses over to us so that we get credit, we're always happy to have it. We also offer everything from custom training, support. We do a ton of hourly things, post-processor edits, custom builds, anything and everything. But you guys don't need to go out and spend all that money if you really don't need it. We have a lot of customers that like the beer and steak program to help support this channel and to just get a quick answer when you need it. So if you guys have no further questions, I am going to go catch the Too Tall Toby CAD vs. CAD system again. Now it is SolidWorks only this week, I think. I don't think there's any. We have 2 Fusions users in the top 4, and I'm ecstatic about that. But outside of that, you guys have a great rest of your weekend. And if you do think of something and need help, feel free to use the support email address down below. Thanks, guys.